Hello. Am I up and running? Yes, I think I'm up and running. Okay. So, discussion in chat was getting to the point where I was like, why don't I just fire up the stream and start talking to people? Um, just to make sure everyone can hear me. We'll just see how long the chat delay is, but I'm sure it's not that long. Um, oh, Dean's here. Dean, I haven't made you a moderator of this YouTube channel yet. Although I thought I had. I don't know. Anyway, we'll sort that out afterwards. Um, so there were questions about how to shrink the amount of code that you have to write for what's it called, number words or something like that. That's a really interesting one. I'm not going to tell you how to do it, but I'm going to give you an idea. So if I have a piece of paper, oh, I've got some bits of paper here, but they're all just kind of like being used for other things. Okay, got a piece of paper here. Let me just... I'm going to take over the screen for a bit. There you go, the only time you're ever going to see me full face. Alright. Piece of paper like this. I've got a whole bunch of if statements, maybe, on this piece of paper, but who knows. If I want to put a hole in this piece of paper, I'm just going to grab... I have random stuff like this on my desk, right? These are sculpting tools for stuff I do with miniatures. So I want to put a hole in this piece of paper. I put one hole in this piece of paper like this. That's my one hole. This is like an if statement. You can put lots of if statements in this piece of paper by just like punching it multiple times in multiple holes. However, if I fold this piece of paper and punch a hole in it, I have two holes for the price of one. If I fold it again, I don't know if you need to fold it again, but I fold it again, and then I'm going to punch through the same hole. There we go. Put that down. I have four holes because I folded the paper before I punched the holes in it. This is what we can do sometimes if we put if statements inside other if statements. That's all I'm going to say. I'm not going to like throw away the whole challenge for everyone by giving you the answers, but maybe that gives you some ideas about how if you're doing things multiple times, you may not have to do them multiple times. There may be ways to have one if statement or another if statement count for multiple possible things at a time. What was the other one? The Easter one, people were talking about working with working with words. What we're going to do with something like that at this point, because we haven't done words yet or anything, is just think about what you would print at a particular time and then just print the word only then, rather than having to store words along the way, and rather than having to like try to build up a series of words that's going to be the date or anything like that. Just go into different if statements and then print out the right thing at the end of those if statements. What are we doing? Oh, Jeffrey says can confirm that analogy, so hopefully that works. Jason's saying that maybe that gives you an idea. So little things like that, right? I don't want to tell you what it is because I think this is like hilarious thing about teaching, right? Is I'm not actually here to give you the answers. If I give you the answers, all I'm doing is taking away your chance to learn how to get there yourself. It's always much, much better if you find your own way to something, because then you remember every step along the way. You're much more likely to remember the process, which is why I'm more likely to put goals in front of you than I'm ever to give you straight answers to things. It's always the funniest thing is you get the teachers and sometimes the um, the teachers that people often find the most interesting in hindsight are the ones that actually never told them anything. It's just like that teacher actually never gave us any information ever. All they ever did was ask us questions, and then we had to figure out the answers for ourselves. Damn it, why do I like that teacher so much? And it's because you learnt more with that person. So that's what I'm trying to do here. I'm just going to give you like a random thing where I poked a piece of paper with a piece of metal, and see where you go with it. Okay. I will shrink myself back down and off into the corner. Um, right, and Dean's saying that certain variables are not really. Um, some of them don't really have a name. Like we get the kind of thing. Oh, today I'm going to show you a place where you can use a variable with a single letter name because there's no real name for it in particular, and it's actually a very common coding convention for us to use a single letter variable for a particular type of thing. However, we are now past 4 p.m. We've had a little bit of discussion about some of the lab exercises this week. If you haven't done your lab yet this week, don't worry about it. You can get there, but maybe you will remember my my folding paper folder paping my paper folding example when you come to using more than one if statement inside another if statement. Okay, let's get into it. I'm on a VLab window here, but I'm gonna swap across to my slides and get going. All right, we're in our second week now. I hope that everyone has had a chance now to get some kind of setup going at home so you can do your programming. If you haven't, there is help available for this. The first of the 1511 help sessions, these help sessions are actually shared between us and other subjects, but Dean, who is in chat right now, is going to be running the help session directly after this lecture starting 6 p.m. So I will stick around for my usual Q&A, but if you want one-on-one help with anything, you can go across to the help session. The link will be on the course webpage. I think it's already up, isn't it, Dean? I'm pretty sure it was already up. And there's information there about how to connect to the Blackboard Collaborate session for that. It's the same kind of session that you've been using for your tutorials and labs. So you can always hop on there, talk to a tutor one-on-one, and if you need to do anything like get help getting set up with something like VLab or another system that you're going to use to connect, like SSH or something like that, you can actually talk to the tutor about that so you can get your program going. Because we kind of want to get everyone programming as soon as we can, rather than necessarily having people have to spend too much time on configuration issues and stuff like that. Yes, people are already lining up times to talk to Dean in the help session, which is great. I haven't necessarily talked that much about how I'm spacing out my code and structuring it yet. So what I'm going to start off with is giving you some things you can write with code, and slowly sort of sneaking in the idea of indentation and variable names and stuff like that. But next week we are definitely going to sort of knuckle down, or I'm going to spend some lecture time looking at this and say, okay, why is pretty looking code important to us? Although I think I've already sort of made that argument to you, that the nicer our code is to look at, the easier it is for us to see what's going on and make less mistakes, that kind of thing. But I'm going to give you some specific examples of things we can do, but that's next week. This week I have one concept I want to teach you, and that's the entire lecture today is based around just a single concept. And I will I'll show you how that works in a second. But Eric was asking there about where can we find the help session. There should be a link on our course webpage at the moment, on our WebCMS webpage. So somewhere in the menu there should be something saying help sessions, because Tom mentioned to me earlier that he'd got that going, so that should be fine. And Dean's here now, so you can ask him for specifics, because Dean can actually look it up, whereas I'm working on this right now. Matthew, I just removed some if statements. Damn the effectiveness of your unspecific paper analogy. Zuckburger. Um, of course, that's your real name, isn't it? That would be really rude if your real name was actually Zuckburger. Um, okay, let's get into it. Today, actually, I should do my usual thing. What did we learn last lecture? Last lecture we put together everything that we'd seen before, so we're still early enough in the course that we're actually thinking about everything that we've done. So, we did take a look at problem solving. So we looked at the idea that there's never going to be a single solution to a problem, especially not with something as complex as programming. So there isn't always just a single path to every solution, and everyone's code is going to look a little bit different. However, we do want to think about whether what we're doing solves the problem in the way that we expect it to be solved. So when it's at a simple level, stuff like your lab exercises and things, we can always think about, okay, what was the original question we were asked? And if we had an original question we were asked, how do we solve our problems? Like if we're running our auto tests and say half of the tests are passing, half the tests are failing, we can see something is a problem, and we can see something that's trying to tell us, the auto test is trying to tell us there are certain problems. But often what we might want to do is go back to the source and say, okay, what exactly did the question ask us to do? Because the question is the main thing. The auto test is just some evidence of whether something is working or not. It's never incontrovertible proof that something is working or not. Whereas going back to the question and saying, okay, I've answered this question, this feels right, is usually a better way to go about it. And that way you can tailor your choice of solutions to something that actually matches the problem well. We continued the work we were doing with if and else statements. And no, sorry about the paper analogy. I just did that before the lecture started because people were talking about tutorial things. So what I did, this is the short version of it, is I folded this piece of paper and then I poked a hole in it. So I only poked one hole, but I've got 4 holes. That's the very short version of the paper analogy, and we can think about those holes as if statements, and maybe we can use if statements inside other if statements so that we don't have to do them as often. That was just a question about challenge exercises, so you can safely ignore that, although it's a useful thing to learn about. So you ignore it, but also let it simmer in your brain, and then later on it might come in handy. People appreciate that analogy. I made that up on the spot as well. I was pretty happy with that. It was like, what's on my desk that I can show this with? And I was like, okay. All right. So we did some if and else statements, but we did this under the guise of problem solving. We also used modulus, which is interesting. So we learned that modulus giving us remainders allows us to do interesting things with numbers. We had our first sort of piecing together of multiple relational operator questions using a logical operator. So it was like, if a number is less than 1 or less than the minimum or higher than the maximum, then it's outside the range. And so that was us chaining questions together. So we took the code that we looked at in the first week and we just sort of built a little bit more on top of that. And so we got a bit of usefulness going on with what we're doing there. Today, we are going to be continuing by adding a new concept, and I'm going to cover this entire concept just like, well, not, I'm going to use this entire lecture just for this one concept, which is looping. And it's the idea that if we have repetitive tasks, if we have a program that wants to do the same thing multiple times, or very similar things multiple times, then we really shouldn't be writing the code more than once. We should have a structure so that the same piece of code can run more than once. We're going to use the structure which is in programming called a loop. There are many different types of loops in programming, and we're going to look at the simplest form of loop that exists, which is called the while loop. This loop, being the simplest of all loops, just means that it doesn't have any bells and whistles, and it doesn't do anything automatically for you. But the nice thing about it is it, in the way that it works, there's all these other loops out there. There's for loops, there's do while loops, I can't actually remember what other loops there are. There are other loops as well, but the while loop can actually do anything that nearly I think anything that all the other loops can do. So that's why we start with this one. It's simple and it doesn't have anything weird you need to think about, and we just focus on exactly what it does. In order to repeat code, we need to look at how to start and stop these, and we're going to look at an example today. I'm actually going to do more coding today than I did previously. I'm going to try to dedicate more than half of the lecture. We'll see how we go to looping. One of the examples that you could see quite easily last week, and we had a lot of discussion about this, was if my user was to type in the incorrect the incorrect sort of values for the dice, what if we didn't correct what they did, but what if we just asked them to type in the number again? And that's something we could do with looping. So we could loop the code to receive a number multiple times, run that multiple times, and then stop repeating that code once we got a valid input. So that's something we could do. We could also do something like when we need to take in a value for one of the dice, and then we need to take in a value for the other dice, and the code for receiving the values of the dice is really, really similar. Maybe we could do something where we just ran the same code twice for both dice, and then save the numbers and then move on and do other things. There's definitely ways that could work as well. So what we can do with looping is anytime that we need to repeat ourselves, we really don't want to be writing the same code again, because if we copy paste the same code, we end up with like a whole lot of risks. So one, like, okay, here's an example. Do I have any examples? No, I didn't put any examples in here. I just had the stuff that I was talking about. So this is what I was talking about. When we use if statements, we can turn on or off parts of our code, right? The if statement literally just is like, what's inside my curly brackets either runs or doesn't run, depending on the if. But if we wanted to run the same code more than once, we didn't have that capability. We're going to add that capability in now. If, for example, I had a program that was supposed to calculate the marks for everyone in the course, that's 750 roughly of you. I definitely do not want a program that says student 1 like marks equals 80, student 2 marks equals 60, student 3 marks equals 40, etc, 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 down the whole 750 people. Like, I definitely do not want to do something like that. So that's the kind of thing where I'd want to have some kind of looping for that instead. I can't remember whether this is, like, in the back of my head I've used this example somewhere, and I can't remember where. Either it's coming later in the course or it's something that I removed when I was talking about looping. So, if I want to do the same thing multiple times, I want the same code to be able to run multiple times. And maybe some of the information in this is slightly different, but what I don't want to do is I don't want to have the same code repeated again and again and again. That leads to some pretty big mistakes, because if there's something in that code that I've copy pasted 750 times and I want to change it, I'm going to have to go through all 750 of those and replace it. So it's really, really fiddly. Instead, I'd like to have one piece of code with a little thing around it saying, okay, run this thing 750 times. I'm like, okay, that's much easier for me to deal with. So it looks a bit like this. Someone's asking about shortcut keys for relational operators. I don't think there are. However, you can record macros. I don't think you can in Gedit, but some other editors, or even just some applications on your keyboard, you can record macros that you could just press like shift bracket or something and it would open and close the brackets and stuff. I've seen people do that. Oh, Maybell's saying, yeah, exactly when we mistakenly changed die 1 code but not die 2 code. It was die 2, not die 1. Yeah. So you're seeing already that once you copy paste code, it's fraught with issues. And then you get someone who like supposedly knows what they're doing, just making such a simple mistake. And then for a moment there, I was like, why is my code not working? The code is written perfectly. And I was like, yeah, super interesting. Um, do, 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 do. I write some of the code to mark your assessments. Yes. Um, I do get other people to write some of that code as well. Like Tom, the subject admin, has to write a lot of that. Anyway, here is a while loop. In the format of the while loop that you see here, you'll notice that it is very similar to an if statement. The only thing that's different between this and an if statement is the keyword. So, the if statement had a question and an answer. I like to think of it as a question and an answer, right? The question's up here in the expression and the answer is here in this code. A while loop runs exactly the same as an if statement for the majority of what it does. What it does is when we get to this line, it says, okay, check the expression. I check the expression. If the expression is true, then we run what's inside the curly brackets. That is exactly the same as an if statement. If the expression is false, we skip over what's in the curly brackets and we go to what's afterwards. The only difference between a while loop and an if statement is if I do run what's inside and I get to the end of the curly brackets, I go back to the start again. I go back to the word while, and then I come in here and I check the expression again to see if it was true. If it's true, then I run and I get to the end and I come back here and check again. So I'll keep going through this while loop until the expression is false. So you can sort of see already how we're going to use this, is that maybe this expression that we're checking is something that's not absolutely true or absolutely false. It's something that depends on a variable, and if we change that variable, we can change whether the loop's going to run again or not. And I'm going to show you two particular techniques that are the most common ways to use while loops. There's other ways to use them, but if we remember these two most common ways, we'll be able to solve the majority of problems that we're going to see. So, while is a C keyword. Same as if, same as main. What other ones have we seen? Same as int, same as double. You can't use it as a variable name. That would confuse people as well. So it's limited. It's limited to be used exactly in these loops. The question and answer thing, as I said before, very similar to the if statement. This is just the text for what I just said, actually. If it's true, the body of the loop runs. If it's false, we won't run the body of the loop, so everything's in the curly brackets. We'll skip over it and just continue the rest of our code. But the difference between it and the if statement is we run the while loop code. When we reach the end of the curly brackets section, we'll go back to the start of the while loop and we'll check the expression again and keep going. So one thing that I want everyone to remember is that anytime that we are going to create a loop, so anytime we're going to put a loop in our code, anything that can repeat itself, the most important thing to think about is how is it going to stop? So before we make any loop, we think, okay, how is this going to stop? Then we can go ahead and make the loop. Because if we've made something that's repeating, we haven't thought about how it's going to stop, it may end up repeating forever. So, two ways I said that we're going to do this. One of them is a counter. So one kind of loop that I might want to run says, I want to run an exact number of times. So I know exactly how many times I need to run, and then I'm going to use a variable, a number variable, to count how many times I've run. And it knowing how many times I've run means it knows when it wants to stop. So I can definitely put a condition saying, if I've run this a certain number of times, based on a variable that's counting how many times stuff happens, then I can make it stop after that. So that's this first one here, using a loop counter. I have an integer that is made outside the loop, so it's made before the loop even starts, and it counts how many times the loop ran. And we can check a condition inside the expression that says, okay, has this thing run a certain number of times? The other thing we can do is decide to exit the loop at any particular time. So I can say, I have a variable that says whether I'm going to stay in the loop or leave the loop, and I'm just going to flick that from one value to another when I need to. So there's a reason why my dice checker was structured in the way it was in last week's example. It has two examples of things that we could make better with loops. So the reading in of dice numbers that we do twice, That is something that we could do with a loop counter. So we could say, I want to do reading in die numbers exactly twice. And if I did it with a loop counter, I could then do something really interesting and say, how many dice are we rolling? Maybe I'm rolling 4 dice at once. If I'm rolling 4 dice at once, then the loop counter goes up to 4. If I'm rolling 2 dice at once, the loop counter goes up to 2. But it's exactly the kind of thing that if we did it with a loop, we'd have one piece of code for reading in die numbers, and we just run it as many times as we need to for the number of dice we're rolling. It gets a bit awkward when trying to figure out which variables to put it in, but it's okay. We're not actually going to look at that example again. We're going to look at something else. But the other example here is, what if I decide to exit the loop only if things are working? So what I could do is I could say, let's run the checking for valid input potentially an infinite number of times. We can just keep running it until the user gives us correct input. If the user gives us correct input, then we'll exit the loop we're in and continue. So what we could do is say to the user, that's not valid, and just keep waiting until they type in something valid and do it. So both of these types of loops could have helped us with the dice checking program that we were working on. We're going to continue with dice stuff today, actually, but it's a slightly different program because I want to show looping in this one, so it's a little bit different. Mason is asking about for loops. I'm just not going to use for loops. We're not even going to use for loops in this course. They are very common. They're very common out there in the world, and they're made specifically for this type of thing, the counter loop, and they're kind of easy to set up. But even we can do the same thing in a while loop, but the beauty of doing it in a while loop is if you read line by line from top to bottom, it does everything exactly in order. Whereas the for loop has things that happen out of order because they're all up on the top line. So it's a little bit more confusing, which is why I'm only using while loops. While loops and for loops can do pretty much exactly the same thing though. But I just prefer the while loop format because it's easy to read for someone who's never read code before. Jeffrey's saying a similar thing, I think, to what I said. Tiara's asking about weekly quizzes and tests. The weekly tests that we have are going to start in week 3. So we will release the first one of those in nearly exactly 1 week's time. And those are things where you can just keep track of where you were up to up until this point. So the first one is going to be based on this week's content. So this week's content in the tutorials and labs is if statements and things like that. So the first weekly test will be about them. The one the week after that will probably be about loops because the next week's tutorials and labs are going to be covering the stuff that we did today. Okay. Let's look at the first example. The first one is a loop with a counter. So here I have my counter, and it's an integer. So it's going to be a whole number because we're not going to think about the loop running a fractional number of times. We're going to think about the loop running an exact number of times. And I can say, I want this loop to run 10 times. Counter starts at 0. This is a kind of a programming way of doing things, but also it has a lot of value to us. So I'm starting at 0 rather than 1. A couple of reasons why I'm doing this. You'll find out later when we start using collections of information why we start at 0, but starting at 0 here also gives us this useful information. When I'm inside the while loop at any time at the start of the while loop, I know that the code has run counter, as in this variable counter, number of times. So the first time I come in here, I know that this code has run 0 number of times, like it has not run before, which is which lets us read that variable and know how many times the loop is finished before. So the question in here is the counter less than 10. I want to run this exactly 10 times. So the counter less than 10 means that no matter what, when this variable is less than 10, this will run, and then we'll have some code in here that does something. Maybe I want to repeat something 10 times, and then here we'll say counter equals counter plus 1. So what I'm doing is I'm taking whatever number's in counter and I'm adding 1 to it, and then I'm storing it in counter. So when this loop finishes, counter will be equal to 1. And then it will come back up here to the while, and it will check that counter is less than 10, 1 is still less than 10, 0 is less than 10, 1 is less than 10. So it will run again, and when we're in here now, we know that the loop has run once previously because the counter is equal to 1. Now that we're in here the second time, we'll go through, do whatever we're going to do. Maybe we're using the counter as a number for something, or maybe we're just doing some repeated task. And then the counter equals counter plus 1 happens again, and it says, okay, we have now run this thing twice. Let's go back up and find out whether that's the right number of times. We're still supposed to continue until counter equals 10. When counter equals 10, then we've run this thing exactly 10 times. And we'll come up here and it'll say, you're no longer less than 10, which means I'm happy you've run exactly the right number of times. It's the same way as if an if statement fails. Here, it will then jump to the end of its curly brackets and it'll jump down to here and continue. So this is something that will now allow us to say whatever's inside this curly bracket, whatever code's in here will run exactly 10 times. So this is a very common while loop. This is the kind of thing that we'll be using a fair bit. We're going to do a few of these later today in a big example as well. As I was saying before, we do have to be careful about making sure our loops finish. So, not sure if everyone gets what's in the comments here. I hope you do. I like to put jokes in what I'm doing. If we have a while loop like this one, 1 is less than 2. 1 is always less than 2. The basic fundamental mathematics that we're basing our logic on says that this can never be false. If this question can never be false, then this loop can never end. It will never give you up, and it will never let you down. I was hoping someone would get that. Let's just see what everyone else has been saying. Yeah, James is saying then it's often usually I or J instead of counter. That's a really, really common programming convention. I'm going to use that later on as well. The I is short for iterator. Iterator is like a number that moves along a set of things. So since we don't have sets of things yet, it's harder to talk about that, but I is very common for this variable. So I could actually, if I wanted to say int I equals 0, I is less than 10, I is equal to I plus 1, and that would be a really common way of doing things. We're probably going to start using that terminology fairly soon, because that's a really common programmer standard. Okay. We need to be careful that a loop doesn't go forever. I'll show you a loop that goes forever later, actually. I'll show you one thing I do definitely need to teach you today is how to exit one of your programs if it doesn't stop on its own. Because up until now, what I've been teaching you, programs that couldn't repeat code, they're probably always going to finish. If they're not going to finish, they're going to crash or something like that. But looping code allows you to create a program that won't finish and can't finish. So we need a way to interrupt our program running, make it stop running, and then see what happened. So I'll show you how to get into that in a moment. Okay, one of the other things that we might use is this thing called a sentinel variable. So I will often use something like this integer here saying end loop. And this is nearly like I'm using a number as if it's a true-false value. It's not always a true-false value. Sometimes it's an accumulation of things. But what I'm writing here is code that will keep receiving numbers from our user and checking them to see if they're even or odd. So if the number is even, we're going to continue. If the number is odd, we're going to end the loop. So every time we run the loop, we check that end loop is equal to 0. So we're basically saying, is end loop false? If end loop is false, then we'll continue. So end loop equal to 0. There's other ways we can write this as well, but I just want to make this one super explicit. So if end loop is equal to 0, we make a number, we ask the user to type in a number, we scan in that number. So this is the kind of code we looked at last week for just generally taking input. And then we do an if else here. We say if mod 2 of the number is equal to 0. So if I mod something by 2 and it's equal to 0, that means it's divisible by 2. So that means it's an even number. I'll print even number, and I'll end that if statement. I won't run the else because the if was true, and I'll come again. So basically this code will just keep running and accepting even numbers, unless we type in an odd number. If we type in an odd number, then end loop is equal to 1, so end loop becomes true. When we come up here to the while, I'm asking if end loop is equal to 0. And if I've flicked end loop to 1, then end loop does not equal 0. This question will fail here, in a sense. The while loop will skip over and it'll finish. So this is a way that I can run code which potentially can run forever. So this code is able to keep running as long as I keep putting even numbers in. So if I just keep pressing 2 forever, 2, 4, 6, 8 forever, there's no way this program will ever end. But the second I type in an odd number, this loop will finish, and this program may eventually end, depending on what happens. All of this code is in a demo file that I've got for you. So if you want to play around with these bits of code, you can comment out sections of it, or you can just copy paste this particular part of the code out to see how it works. Someone was asking about stuff like the return and stuff like that. This is not a whole program. If it was inside an int main void with an include standard input output and stuff, then it would be a whole program, but I couldn't fit all that on the slide. So this is just the bit of the program that runs this. People talking about writing infinite loops and breaking computers. Yeah, we can do that. And Dylan figured out the word addition thing. Well, I'm glad that the paper folding thing helps people. Patrick's asking about initiating the input number inside the loop rather than outside. Have I told you about curly brackets before? I have not told you about... I think I have a slide about this later. Let me actually just get to that slide. So, who was it asked that? Patrick, I will get to that in a moment. The difference between making an integer inside a set of curly brackets or outside a set of curly brackets, and what happens with them. Jen is saying, so end loop doesn't always have to equal 0. It doesn't, right? So we're asking if it's equal to 0. So here we're setting it to 0. So before we start, we set it to 0. But then when we run it, we're checking if it's 0. So if it's 0, we run. But if it's not 0, we don't run. And then sometimes, depending on the conditions, we might set it to 1. If we set it to 1, that means our loop never runs again. It finishes the one it's looping now, and then it goes back up here and it checks. I should be equal to 0 if we want to continue running this loop. And then we check and it equals to 1 because we set it to 1. Then we say, okay, loop's finished. And that way we can get this program to behave in a certain way. We can get it to say, keep running if I keep giving you even numbers. So if I keep giving you even numbers, keep running. However, if I give you an odd number, stop running. We could have done this with our dice checker last week. We could have said, keep running if I give you numbers that are below 1 or higher than 6. So if I give you invalid numbers, you've got to keep running again, keep asking me for numbers. But if I give you a number that is between 1 and 6, one of the numbers you want to keep, then you can store it somewhere and you can go, okay, we can end the loop now. And we can exit out and go, oh, sorry, we've got the correct number, the one that we wanted. So you can see how we could use this kind of loop to keep checking things until we get the right answer, and then we keep going. Or to keep allowing something to happen until we get the wrong answer and then stopping it, you know, that kind of thing. So we'll just keep looping until we get a certain condition, and then we end it. Shaik, return 0 is not super important. It's like, actually, even in some of our answers example code, because it's written by different people. Some people will have it, some people won't. It tends to be a convention rather than anything else. Oh yeah, Dean's already answered that. Dean's hanging out. I'm gonna let Dean answer all the chat questions now. Okay. So, because everyone loves memes. Hang on. His face is that way. Hey, there you go. So, yo dog, I heard you like loops. So I put a loop inside your loop so you can loop while you loop. this is an interesting thing. We can put loops inside other loops. So basically anywhere where there's code, we can put code. That's just a tiny bit confusing. Which means, like I was saying, I think this was on Tuesday I was saying this, or even last week, we could put if statements inside if statements. We can put a different set of if-else statements inside an if statement. We can put a while loop inside an if statement. We can put an if statement inside a while loop, etc., etc. We can put while loops inside while loops. And the interesting thing about putting a while loop inside another while loop is that the loop on the outside will run, say, 10 times. Let's say they're both running 10 times. The loop on the inside will run 10 times, which means that everything that we do inside the inner loop runs 100 times, because every time the outer loop runs, the inner loop runs lots. I've got an example. Wait, here we go. Wait, I just need to put my face out of the way for a moment. And yes, people are saying this sounds confusing. It is confusing, so I'll show you some code. So, I can do a loop within a loop. I wonder if I should show you this code working. I'm gonna super quickly jump across to VLab, because I think I might as well show you some practical stuff here with some looping. Alright, ls, see where I am. Going to change directory to COMP1511. Check out what I've got here. I need to make a directory for lecture 4, and then I will go into that directory. Alright, I don't have anything in here yet. I'm going to make something called loop demo just to show you some things. Oops. Just gave myself another subject to teach by accident. Okay, basic starting of any program. I am first going to include my standard io.h. I don't always need this, but for the majority of the programs we're using, we're going to use standard input-output, because without it we won't be able to see anything on screen. There's plenty of programs you can write that don't use it and don't need it, but most everything that we're doing at this point will be using it. Got my int main void. For Shayak there, I'm going to leave out return 0 this time, and I'm not going to lose any marks. It's because I've got all the marks, I just give them away. But, you know, just showing that it's not actually a super crucial part of the code. Okay. Where do we go? Oh god. We have devolved into Rocket League in the chat. I'm going to ignore the chat because you've devolved into Rocket League. I don't actually play Rocket League. I apologize. Okay. So let's look at some simple looping code. So I'm going to do a loop that loops exactly 10 times. So I'm going to use this terminology with the I. So I is known as iterator sometimes, and then I'm going to create a while loop based on this. Again, doing all my brackets first. Someone was talking about, like, are there keyboard shortcuts to do that kind of thing? I don't know if gedit has it, but I know that there are other systems that people use sometimes where they can just press a series of sort of command keys and stuff like that, or macros. Some keyboards have keys that don't map to the keyboard, but they map to programmable things. And you could actually do something where you press one button and this whole bit of text here for the while loop pops up. So I've seen people do it. It could be handy. I mean, it's a little bit of effort to set it up, but then after that you're going to be a bit quicker every time you want to do something, so up to you. Especially works out okay because we're not forcing you to use our computers for the exam this term, so you could actually have those shortcuts if you want to. Anyway, if I want this thing to run 10 times, then I want my I to be less than... Ooh. I just rickrolled myself. I want my I to be less than 10, which means if I'm doing this in my loop somewhere, then this thing is going to run exactly 10 times. I'm going to leave that comment there. It's nice to have these little comments here to remind us exactly of what we're doing. So every time I open this curly brackets and enter this piece of code, I know exactly how many times this thing is run because it's the value of I. Just so that we can see this running, because if I just run this now, you're not going to see anything, but I'm going to put a printf in here so that we can see this running. And I'm just going to print a star. Actually, that's it. Just going to print a star. So I should get a line of stars, and I should have exactly 10 of them when I run this. Loop demo. I'm going to call it stars, because it's just doing stars for the moment. Run stars. I didn't put a new line on the end, so my terminal's like right on the end of it, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. I have 10 stars. So I have one printf statement printing out a single star, but because I put it in a while loop that was running exactly 10 times, because I have this 10 here, then I got 10 stars. Maybe I'll put a new line on the end of that by printing out this new line here. So I'll just compile that again using my up and down arrow keys to get my previous compilation command. Run stars. Cool. I have 10 stars there printed out because I looped this 10 times. Let's see what people are saying in chat. Shayx making the regular pun about my name being Marc. I always like to give out bonus marks that are spelt Marc with a C. They don't actually do anything for your university grades or anything, but they're just things that I think would be cool for you to do. Okay, people are tagging me a little bit here. Mason is asking about the final exam. Don't worry too much about the final exam yet, but you will be running them on your own computers, so you can have your own setup and use your own setup. So our final exam, as it says in the course outline, if you want to go, there's more detail there, is a 24-hour take-home exam, which means you have access to Google. You can actually even look up lecture slides, like anything like that. Actually, that's the best, really, because if you go through my lecture slides and then answer the questions that I wrote, it's, you know, I'm never going to ask you something in the exam that doesn't have like the grounding, the basis in what I taught you. So it's interesting like that. Okay, other questions. What's the best keyboard for coding? I don't know, lots of them. A lot of people swear by mechanical switch keyboards, and it depends on what kind of mechanical switch keyboard you get, how loud it is, and how annoying it is for people around you. So always take care of that, because that's, yeah. Many offices have been torn apart in rebellion by mechanical switch keyboards. Cosmo is asking about using your own editor and then copy and pasting the code over to VLab for testing. Yeah, you can totally do that if you want to. So you could edit on your own computer, copy the file into something like VLab, and then run things like auto test and stuff like that, or DCC that has all of our, you know, more detailed compilation and stuff like that. Pooja is asking, why do I enter I equals 0? So this one here, I equals 0 allows me to set up a value for I to start with. So I equals 0, I is a variable that tells me how many times the loop has run. So if it's going to tell me how many times the loop has run, it's going to start at 0 for me to be able to say the loop has not run yet. So that's why I'm starting it at 0. Instead of, say, the potential is I could start it at 1 and count a slightly different way, but then it wouldn't be the loop as run an exact number of times, right? We are actually going to try that later, because I'm going to do some dice stuff, and dice stuff is going to start at 1 rather than 0. Oh, hello. Can you hear that? I don't know if people can hear that or not. You going to say hi to everyone? Alright, we got special guests. Person everyone wants to see all the time. Chicken's here to tell me that I'm coding wrong. There you go. Alright, there she goes. She's going off on her merry way, but she was very, very loudly wanting to say hello. Yes. And people are saying it runs 10 times. 0 through to 9 are the numbers that it's going to be while it's running each time. Because every time it runs, it says this is how many times I've run previously. So 0 through to 9. So the 10th time it'll run with the number 9. Someone's asking if I'm going to do a triangle of n lines where n is a user input. I'm not necessarily going to do that here and now. There's a different example I want to do today, but I'll show you a square grid, at least. What swear word is 10 stars? It's a very creative one. Someone's just noticed all my stuff down here. Yes. Normally, I wouldn't be lecturing on my gaming machine, but I accidentally left my work computer at CSE before the lockdown started, and I still haven't gone back since. I probably could just go back and pick it up, but now I can't be bothered because I've actually got a whole lecturing setup set up on my gaming computer now, which makes me even more of a streamer than I would have been otherwise. Anyway, so Cherry Blossom says Corsair is good. Oh wait, you're laughing at the fact that I've got some Corsair stuff somewhere? No, I don't. Do I? I have one here. Corsair mouse. Anyway, let's move on. And the chat is full of everyone noticing the chicken turned up. Oh my god, look at that chat. Okay. Actual question about code. Why did I put this printf line at the end? The only reason I put this here was so that instead of getting this situation where my prompt appears directly after the text from my program output, I want the prompt to appear on the line after. So I just want it to separate itself a little bit. That's why I put the new line there. So it's like saying print your 10 stars, then press the enter key so that my terminal doesn't get messy like that. Someone's asking if we can use stuff we haven't learnt yet in the challenge exercise. We can't really. We're actually set up to check whether you're trying to use stuff that's not that we haven't taught you that for the challenges. So the challenges are there for you to expand on what we've taught you, but not necessarily jump to something that we haven't taught yet. So often the limitation is there to see if you can creatively use the things that we've given you. So it's kind of like, if we hold you back a little, can you get creative on what you're going to do? Rather than, is there some other programming tool that exists that's already going to solve this problem? Because if we wanted to, we could just be like, every single thing you can do in this course has already been solved by other people. Because this is an introductory course, right? We're just bringing you into programming. So if you were to take some of the questions I'm asking you now and post them on Stack Overflow and say, okay, how do I do this? People would be like, you really shouldn't be asking this here. This is like for higher level questions than that. That question has been answered 1,000 times by everyone who's ever used this, in a sense. So a lot of the questions, if you were, say, you'd been programming for 2 or 3 years, you'd consider some of these questions to be redundant. But that's also why I would prefer you to do things only with what I've taught so far, because what this is there for you to cement specific knowledge about things. Word addition, you're using string and character arrays. I think that we're not supposed to use arrays in that, but I can't. Yeah, Priya, yeah, people on Stack Overflow are so mean. Yeah, I'm totally with you there. That's why I warned everyone when we looked at Stack Overflow last week. Tuesday. I was saying that Stack Overflow, yes, may have the answers, but may have just a bunch of people trying to prove themselves, or a bunch of people trying to show off about how complicated they can make something. So I often would prefer to use the 1511 forums than something like Stack Overflow, because there's no agenda on our forums. There's no one trying to make themselves look bigger than other people. Like, instead it's people who are like, our whole purpose here in working on these forums is to help each other. So it's an environment I much prefer. Honestly, I prefer that kind of environment in general. Like, I don't even want to work somewhere like in a professional sense where people are always competing with each other. It's just kind of like, you know. Anyway, let's go on. Okay. So my stars program is putting 10 stars on a line. What if I want to do a big cube of stars? Let me show you something cool. This whole section of code, so I'm gonna give us some white space on either side of this section of code and put a comment here. Write one line of stars and a new line. So that's really precisely what's happening here. That's all that's happening. I write one line of stars exactly by looping 10 times and a new line. If I want to make a square of stars, we're not doing 3D yet, a square of stars, then what we can do is we can write 10 of these lines. If I want to write 10 of these lines, what kind of code would I want to do to write 10 of these lines? I will show you what kind of code. What we do is we copy this and then we paste it 10 times. Is everyone screaming? Is everyone going, no, Mark, why would you do that? Yes, see, Chicken is also saying, Mark, why would you do that? This is incorrect. It's really bad. Because now I have the same code over and I don't even know if I copy paste that 10 times. Actually, you know what? I'm going to save this and run this and see what happens. Okay. Oh no, previous definition. Errors, I have the same thing. Oh god. Okay. I'm not even going to go through those errors. I have too many errors, and this was a bad idea. I'm going to press Control Z, which is undo, to get rid of all this copy paste. So this is an example of what would happen if I didn't think about my looping and tried to just run the same code over and over and over again. However, if I do want to do this same code over and again without necessarily causing all these problems, I can write another loop. So I don't want to use the same I that I have in there, so I'm going to use a different counter variable. I can use J if I want to. Some people use I and J. They usually use I first, then J, but I'm doing it differently because of the way I'm doing it right now. And then I'm going to create a while loop. Again, I'm going to create these things in isolation and then put the code in that I need to be in there. So if I want to do this 10 times, J has to go up until 10. And then J gets incremented. That's what we call it. Incremented just means go up by 1. Every time we loop, J gets incremented. I'm going to put a comment in here to remind myself. Loop has run J times. And then in here, I'm going to run some code, right? So in here, I want to do something. So if the thing that I want to do is write one line of stars, I can take this code here. I'm going to press Control X, which is going to cut that. So it's going to disappear from where it was, and Control V to paste it. My indenting is really weird now. It's really confusing as to seeing which part is inside which other part. So I'm going to fix up my indentation by saying this while loop goes from here to here. Everything that's in this while loop needs to be indented 4 spaces further in. So I'm going to select all of this stuff, which has been incorrectly indented now. It's too far out. I'm press Tab, and it's going to indent it further in. So here's a trick that we can do. We can change the indent level of something by pressing Tab or Shift Tab. So Shift Tab moves it backwards, Tab moves it forwards. This level of indenting is where I want it. So inside my main here, everything that's inside my main is at this level of indentation. Then I open a while loop and I open another set of curly brackets. When I open another set of curly brackets, I go one level deeper with the indentation. So it goes 4 spaces in here. And then I open another set of curly brackets for this while loop and I go 4 spaces further. So what I have done here is, first while loop I created was this one to just write one line of stars. The second while loop is this one that just makes this code run again. So I have a loop within a loop, which means one of the loops is drawing a line, and the other loops is drawing several lines. And with that, I can draw a square. So let's save this, compile it, and run it. Hey! It's not a square exactly because the shape of a character in my terminal is not a square shape, it's a rectangle. So it's taller than it is wide, so my 10 by 10 grid of stars was taller than it was wide. But this is a simple example of doing one loop here, and then maybe putting it inside a loop so that I could do another of the same. Chicken is horrified. I'm just going back over the chat here and people like, what? What is he doing? Why would you do that? Yeah. Okay. Good. I'm glad that other people were screaming when I did the copy paste. Oh, Charles is saying, yeah, you can actually copy paste it. If it was 4, that would have copy pasted. Yeah. Anyway. Not hugely important either way, because we don't want to copy paste our code. Carol's asking if there is a shorthand for incrementing. There is shorthand for incrementing, and there is a slide about shorthand for incrementing in this lecture. So when I get back to actually going through the slides and stuff, we will actually see that. Okay, all right. Let's go back to my slides. Okay, so this is this thing here, the loop within a loop that we can do. And I also just wanted to show you some code of looping there. So we draw the grid of stars and stuff. I don't need to go through this slide, actually. Okay, question from earlier. I apologize, I can't remember who asked the question earlier. What do the curly brackets do? So, interesting things. So that grid drawing code that we had before, I think I did it with an X and a Y in that one. Oh, Y for rows and X for columns. That makes a lot of sense. Past Marc had some thoughts about that worked. So X is contained inside these curly brackets here. So we create it inside these curly brackets, and we use it inside these curly brackets. It doesn't exist outside the curly brackets. So let me show you an example back to what I have here. So I create I here. So as we said before, when we create a variable, then that variable is available. It's a piece of memory that we can use and change its value. If I do this, printf last value of I was this. I'll put a new line in there just to be nice. And that's I. We can think of this and go, okay, this should work. Int I exists, and I'm just printing out its value. Let's compile this. So DCC there. Oh, error. Use of undeclared identifier I. And here's an explanation from DCC. So this is something you'll get from DCC that you don't get from other compilers. Means you've used I, which hasn't been defined. So I is a variable that doesn't exist, or we haven't declared it, etc. The interesting thing is I think it exists because it's here, but this is what happens with the curly brackets. So the curly brackets establishes what I call scope. Scope is a certain package of lines of code, and the way I remember this and the way I like to teach this is the Vegas rule of curly brackets. Whatever goes on inside the curly brackets stays inside the curly brackets. So whatever is created in here only lasts until the curly bracket closes, and then it disappears. There's a reason why the J is outside of the while loop. Because if I made a J inside the while loop, it would get reset each time, and then it wouldn't necessarily accumulate to J is equal to 10 and exit the loop. This I has to be outside the curly brackets of this while loop because it governs this loop, and so it has to exist when the loop doesn't. However, the I is inside this loop, which means it only exists for this piece of code And once it hits this curly bracket, the I ceases to exist. So that's something that we're going to see a little bit once we start looping and we have more of these curly brackets happening. Is every time we have curly brackets, if we make something inside those curly brackets, it will only live as long as the curly brackets happen. So whatever goes on inside the curly brackets stays inside the curly brackets. The reason why something like this J can extend outside the curly brackets is because we're changing a variable that exists outside the curly brackets. And that's why the J actually kind of persists through multiple loops. Oh, Trey and Dean are both there. Oh, we've got two tutors in answering all the questions, so I won't have to look too much at chat there. Okay, so that's one thing. Yeah, just checking what people are talking about. That's cool. All right. Someone was watching the tail. Yeah, Chicken had decided to come and say hi. Michael's asking if the curly bracket rule is only for loops. It's not just for loops. It's for every time that there's curly brackets. So if statements do it as well, and later on when we actually have these things called functions, we're going to see that it works for them as well. Okay, so that's the curly brackets. Let's take a break. Oh, I'm on time, which is really nice. So, I actually mentioned this before. I should put that yo dog meme up here again. An if statement is code. A while loop is code. You can put if statements in while loops. You can put while loops in if statements. You can put a while loop inside a while loop with an if statement inside it. That kind of thing. Just be careful. The more deep that indentation level of what's inside what, it's inside what, etc. goes, the more deep that goes, the more likely the weak flesh brain is to snap and not be able to deal with it. So just take that into account whenever you're making these things. When we get deeper and we start going to the assignments and stuff, we actually have a thing that's actually going to let you know when you've gone too deep in indentation and say, okay, be careful here. You might be confusing people. And you might have already confused yourself and not even know what your own code is doing if you put too many things inside each other. All right, let's take a quick break. I will be back in, say, 3-4 minutes' time. There was actually a request last week. I don't know. Who was it? I think it was Elise who was saying, asking to see if you could see chicken getting fed. I might do that now in the break because it's nearly food time for chicken. I'm not actually sure where she is right now, but if you want to, I might get her food out now and feed her on camera if people are interested. Anyway, I'll go on break and oh, Abraham's back. Hello. It's a student from last term. Okay. I'll go on break now, but I'll see. Maybe I'll feed chicken during the second half. We'll see how we go. All right. I'll be back. Alright, did that work? Okay. Yes? Yes? Alright. I'm just gonna go get her food. I'll be back. Is that on camera? It's not focusing great, but I'm just gonna grab the camera. Alrighty. There you go. A little bit of chicken having her dinner. I mean, you know, it's kind of a more fun break in a lecture than you'd usually get. So there's there's chicken eating her little granules of scientifically prepared granules of cat sustenance that she's been eating for her entire life. I don't know if that has chicken in it or not, but it is in chicken now. Anyway, okay, let's continue. That's a fun break. Um, oh wait, someone's actually asking a programming question. So with the curly brackets, ints can still be expressed outside if they're being edited. Yeah, so we can create something outside the curly brackets that can be used inside the curly brackets. That thing will then be able to exist outside the curly brackets. But anything that we make inside the curly brackets will disappear once the curly brackets end. In a similar way, if we were to think about these curly brackets for our entire program, all of the stuff that we create in here only exists for our program, and it won't suddenly be available for other programs later, you know? So this J won't be accessible to the next program that I run after this, because we hit this curly brackets and it would have closed it off and finished it, and then this J will disappear, this I will disappear at this curly bracket, which means that there's actually 10 of these I's, and each one is created when this loop runs and then destroyed when this loop finishes, and the next time the loop runs a new I will be created and then it will be destroyed, and it will keep going like that. Whereas there's only one J, and the J will be modified 10 times inside this loop, but because it lives outside the curly brackets, it's only one, so it doesn't get repeatedly created and destroyed like that. Yeah. Zenon's saying, does chicken get bored of eating the same meal every day? I don't know. She doesn't seem to mind, and she always wants it no matter what. So she's always begging for food by this time in the evening anyway. Okay. Athena's asking if we can feed chicken in the break every Thursday. Chances are we can. We'll see how we go. Okay, so what are we going to do now? Let us create a program which is similar to what we were doing with dice. Yeah, so we've got the idea of dice, but this time I'm doing a program that I'm calling Dice Statistics. And this program is going to look at rolling 2 dice, and I want it to be able to show me all of the possible ways that I can roll 2 dice. So anyone who's done maths with combinatorial theory or anything like that will know that if I have 2 6-sided dice, I have 6 times 6 possible ways to roll those 2 dice. So that means for every way I can roll 1 die, I can roll the other die and get all the possible outcomes. So if I'm just using 6-sided dice again, got a couple of dice here. Again, for every value that I roll on the first die, I can have 6 values of the other die. So 6 values of one die, 6 values of the other die, 36 possible totals. What I am, 36 possible ways of rolling the dice. It's not actually 36 possible totals. There's less totals than that because some different combinations add up to the same thing. But what I'm going to do is try to put together a program which is going to show me all the different rolls that can be made. And if I pick a number and I say, how many ways are there to roll 7? What is the percentage chance I have of rolling a 7 on 2 dice and adding them together? This program should be able to tell me that, because it should be able to show all the possibilities, check how many are equal to 7, and then tell me what my odds were of rolling that. Someone saying Chicken should write some code. Didn't you know that Chicken writes all of this code? I'm just a servant. All I do is just repeat the things that Chicken has told me previously. Someone start a GoFundMe for Chicken. Chicken Camp. That would be a fun way for me to just make a lot of money, because I don't think Chicken would keep any of that money. I think I would get to keep all the money, but let's not. For the moment. People keep telling me I need to start an Instagram for her, but let's just hold off on that for the moment. Okay, what do we need to do to be able to see all the values of 2 dice? Now, I've already put together a structure that's probably going to work quite well for this. The loop within a loop that created 100 stars is probably going to work the same way for us to be able to create 36 possibilities of the dice. So we can start with that. We can start with the idea that we're going to loop to get all the possible values of the dice. In order to get all the possible values of the dice, I need to add together the values of each die as I roll it. And let's... Actually, yeah. This is another thing that we do with problem solving, is we tend to take a big difficult task. So the big difficult task is, what's the percentage chance of rolling a particular number on the die? What I might do first is go, okay, can we just roll 2 dice and see what all their values are? Let's do that first, and then we'll add in the ability to total them, and then we'll add in the ability to check whether they reached the right total, and then we'll do some percentage calculation and stuff like that, right? But we're going to start with the easy things that we can manage first before we even think about the other things. So this is another thing about, like, when we're dealing with big problems, is breaking it down into parts is quite important. So this is actually following on from what I was saying about problem solving. I am focused on the goal, but I know that I should solve these smaller bits of it first before we get there. So the first thing we're going to do is just try to get all the values that the 2 dice can roll. Chicken invented code. Okay, so I've got some possibilities here where we can actually get the user to tell us how big the dice are. So these may be 6-sided dice, but they may be rolling like 4-sided dice or 8-sided dice or whatever. So we're going to start with taking user input and then setting up 2 dice, and then we can do this while loop thing here. But let me, rather than showing you code like that, I'm actually going to edit some code. Alright, so do we have anything in here? We do not. I will create one. I'm going to call it dice stats, because short for dice statistics. What are we in? We're still in June. Okay. I am going to do my standard input output. I'm going to include properly. Hang on. That's the key next to the one that I wanted. And I have my int main void here. You'll see me do this all the time, right? You see me do this with brackets and other things. Anytime I open something, I complete it before I go in to put the details in it. It just means that things are much more likely to be neat if I do that. Okay. Another thing that I often do when I'm writing code is I'll write the comments first. So if I write the comments first, it can be easier for me to know what I needed to do next. So take user input on the size of the 2 dice. The other thing that I could do if I wanted to is instead of taking user input, I could just hash define it, but that would fix my program in a particular way of running. If I take my user input, it means anytime it runs, the user could change the size of the dice, which is a nice thing to do. Okay, so die 1 size, we're still only going to do 2 dice for now. If we did it with another number of dice, things would get more complicated, so we're not going to that level just yet. So I've got 2 dice, and they have sizes. At the moment, they don't have any size at all. So what I'm going to do is I'm going to ask the user for the size of the 2 dice, and then I'm going to input. I'm going to take their input and store their input in these 2 variables. What did I say in the slides? Please enter the size. Okay, cool. Do that like that, and then a scanf. So it's all going to happen on one line, but the user's going to press enter in the scanf, which is going to take us down to the next line. I'm going to do this as a decimal integer, and then I'm going to say and die 1 size is going to lead scanf to the actual memory location where die 1 size is, so that we can put that information in. I'll do the same thing, for the second die. I probably could have copy pasted this entire line and then just changed stuff. Second die, I will scanf that, and again an integer. This time it's going in the other variable size. Alright, once this little bit of code runs, I should have the numbers in these 2 integer variables for how big the 2 dice are. So if I know how big the 2 dice are, then I know how my loops are going to run for these. C actually stands for chicken. Andrew is saying, have I explained that every single time I've opened and closed brackets? Maybe I can stop explaining that at some point. Okay, so here I will have the user input on the size of the 2 dice. Then I'm going to loop through all the possible values of die 1. Let's just go do die 1 first, and then we'll do the other loop for die 2. So this is not the size of die 1, but this is actually die 1 itself. Because die 1 as a dice variable is going to start at 1 and not 0, we're going to start this at 1. So before, when we were doing a loop with the I, then we were doing it with the I's and J's. We're starting them from 0 because we're counting an exact number of times. This time we're not just counting how many times we're doing something, we're actually saying we want exact values. So we want the values 1 through to 6. And then I'm going to do a while loop, and I'm going to say, if I want to look at all the values 1 through to 6, I'm going to say, oh, actually it's not necessarily 1 through to 6, it's 1 up to the size. I'm going to say we're not just going to do less than die 1 size, because die 1 size is the maximum value. So if we also want to look at the maximum value, we do want to keep doing that one last loop that is equal to the maximum value. So this loop is going to go from 1 through to die 1 size, and it's going to run once for each of those numbers. So if die 1 size was 6, this would loop on 1, 2, 3, 4, 5, 6. As opposed to this program here, with the less than and the 0, this loops 0 through to 9, and it doesn't run on 10. So we're doing a slightly different loop here. We're starting on 1, and we still loop on 6, and we're stopping on 7. That's if these things are 6-sided dice. We'll probably use 6-sided dice to start with, just to make it easier on ourselves. So if I'm going to do this, I can now just do printf. Let's just do 1 on each line of die 1. Okay, so here is a pretty simple while loop, and it's not even going to use the second die for the moment. We're just using the first die, and we're saying, what are all the possible values of the first die? And we do this by looping. So let's just get this going. People may have seen this before, the gedit warnings that you get. This is just tied into gedit doing autocomplete. So autocomplete is like where we start typing a word and it tries to finish. We get warnings sometimes on autocomplete when it's trying to figure out which other words are available for it to use. You can safely ignore these warnings. They won't change how your program's running. So I'm just going to clear that because that wasn't necessary for us to work with. And I'm going to compile this program and see what it does. So it's called dice stats. I'm going to tab to autocomplete that. And the output file, I'm just going to call dice stats as well, because it's the same name. It's the thing that I'm trying to make right now. Reese is asking if we care about the efficiency of code in this course, like how fast it can run. No, we don't. This course is worried about, can we get it going or not? If you want to think about that, if you want to think about ways to make your code do less work to achieve the same result, that's totally fine. You can think about that. You can start working on code to try to lessen the amount of code that has to run for doing things. But this course is more about just getting things going, because this is an introductory course, right? So for a lot of this course, it's like this concept is new, try to get it working. Here's another concept that's new, try to get it working. So we're not worried too much about getting it working well, because that's the second step in terms of like this kind of long journey of programming. The first step is to get stuff to work. The second stuff is to get it to work nicely and elegantly and stuff like that. So for the moment, it's just like, if it works, it works. That's all we're going for. Okay. I'm going to compile this. Shady's asking if we have to type -i when we put the input file for DCC. No, we don't. If we put a C file in a DCC command, it's going to assume that that's the file that we're trying to compile. Okay, we can run die stats now. Enter the size of the first die. I'm gonna make this a 6-sided die. Second die, I'm just putting a 10 in. I know that it's not going to use it, so it's not really that important for the moment. Oh. I appear to have a loop that is running forever. Did anyone notice that? Did anyone notice that I left something out of the loop when I was typing it? Okay. So I wanted to show you this because this is something that can happen. I am now writing an infinite number of ones into my terminal, and this loop is not ending, which means my program is not ending. So I wanted to show you what to do when yours does this. So there's a significant percentage of us, I'm going to say, depending on how much more programming you're going to do in your life, there's 100% of us who are going to write a loop that doesn't end at some point. Now I'm actually just using kind of infinite resources on VLab right now. So if I was to leave this running, I would probably get an email from our system support people just saying, Mark, you've got a program that's sort of going forever, and it looks like it's a demo from a lecture that really shouldn't still be running now. Okay, I'm going to press Control-C on my keyboard. Control-C here. One of the nice things about DCC, which is the compiler that we're using, the compiler being the thing that translated my written code into the program that actually runs, this will tell me what happened. Usually if I press Control-C with another compiler, it just stops. But DCC, we've got it running some stuff so that it actually tracks how things are going, and it tells us what's happening. So it says to me here, dicestats.c stopped and line 19. So this is line 19, where it was printing out the size of die1. The values when the execution stops, die1 was 1, and that was the 1 that we had there. Die1 size was 6, and die2 size was 10. Okay, at least with this I know that my input worked, but die1 never changed. We go back in here and look at line 19. This is line 19. This is everything that's inside our loop. Did anyone notice? I'm sure people noticed. It was Control-C, everyone. So Control-C. It's hard because I'm pressing on my keyboard, but you don't see it. So I'm gonna leave it in here as a comment. The command to stop a program, especially in the case of an infinite loop, is Control-C. Alright. You ever go to those like little those kids shows in like the park and stuff like that, or at the shops where they have like the dastardly villain that pops up on stage, like in the stage show behind the heroes, and everyone's like, "He's behind you! He's behind you!" and the heroes are like, "Where?" And then the villain's already like hidden behind a piece of scenery by that point, and then they don't see him. That's what I always love when I write code like this, because I can always imagine like there's a whole bunch of you there just going, "It's an error! It's an error!" Yeah. Oh, Priya's saying shortcuts don't work on V. You know what you can do, Priya? Stick around after this. Go to the help session and talk to Dean about that. He might be able to look at how your VLab is set up and give you a hand. Oh, Tiara's been to one of those shows. Andrew sounds like he's been to one of those shows as well, which is great. Okay, so hopefully everyone was screaming at their screen going, "Mark, what are you doing?" like when I did the copy paste before. What I had there was, I forgot to do this. Ooh, that's not I. Die1 is equal to die1 plus 1. Now this thing will increment. It will increase at the end of each loop. I'm going to add something to this now. I'm going to show you a new bit of code. Incrementing happens so often in programming that we have a shorthand for it. Die1 plus plus. I have a slide about this. Quick pause for the new syntax. So incrementing just got easier. Die1 is equal to die1 plus 1. Die2 here plus plus. These have the same effect. They will just add 1 to a number. So they will just say the number just gets 1 bigger. So I'm going to use this plus plus a lot in our loops because it's just this shorthand that I'm really used to. So whenever we have a loop counter like this die1, I can just do a plus plus on it. I was going to say we have seen die1 minus 1 values. So I'm just going to, I always put these reminders just inside my loop to say that just when the loop runs, there is some relationship between this variable and the loop itself. So it's easier if it's a 0 because then I don't have to do this minus 1. But here I have seen die1 minus 1 values previously. So up until this point, if die1 is 1, then I've seen 0 of them before. That's the start of the first loop. And at any time through, whatever value die1 is, it will let us know how many things we've done previously. So I like to put that in there. It reminds me of where I am and what I'm doing. Okay, I'm going to press Control S to save this. Up and down arrows to get my compilation command here. I'm going to run that again. Let's just give it 6 and 10 again because they're the same things we had last time. Alright, better. I'm now running this exactly 6 times, and I have all all possible values of that first die. Um, People are asking about plus I. Is very subtle, the difference between I++ and ++I. They change what happens to the number if it is being assigned to a variable, as far as I remember. Don't worry about it too much. I think for most everything we're doing, you could use either one. Or... yeah, the only time it would make a difference if I was going to do something like this. So int value is equal to die1++. Don't quote me on this. I have to look this up because I do this so rarely. Because usually when I do plus plus, I'm only working on this variable. But if I was to set it to another variable, then there's a difference between this plus plus and this. One of them puts the old value in and one of them puts the new value in, but I can't remember which one it is. It's only if that happens. You're definitely going to have to look that one up, because that's not something I know off by heart, because it's such a rare thing to use for me. Zenon's asking if die1++ is the same as die1+1. Die1++ is the same as die1 equals die1+1. So I'll put a semicolon even on the end of it. So this is the same as this. It's just a shorthand. So it's just a way that you can do this without having to type as much stuff, because this is a really common thing to do, the plus plus thing. Yeah, and Weiwei has the right idea there. When a++, the a will be 2, yes. The first time we run it. So when die1 was 1, when we plus it, it becomes 2. The next time we go through the loop, it becomes 3, and then 4, 5, 6, because this is what we're actually printing out. And then eventually, when it becomes 7, the loop will stop running. Ooh. Yeah, I think Jeffrey, I think you know the subtlety there. I can't remember exactly which one is which. Shady, I'm not sure exactly what's going on with your code there, but you might have to hold on to that question and talk about it, and we'll talk about it later, because I need to push on. I've got 25 minutes left, and I've got some more code that I want to write here. So we're going to push on, but like Shady, we'll come back and have a look at that afterwards when we've got time. All right, Dean's confirming that. Yeah. Okay, so this gives me all the values of one die. But what I wanted to do was get all the values of both dice. So what I'm going to do is, for each value of die 1, I'm also going to look at all 6 values of die 2. So if I'm looking at all 6 values of die 2, I'm going to do a really similar loop inside this loop. And just for Andrew, I'm going to talk about how I complete all my brackets before I put the information. Is that like... I think people are going to have like a secret forum somewhere that I'm not on, where they're counting how many times I say the same thing. I'm pretty sure that there must be things that I say over and over and over again. And there can be things, this is like a bingo sheet for the things that that I say, and then if you get all of them, you can all yell out bingo in chat. Okay. So die 2 here is going to go up until die 2 size. And this time I'm going to remember to increment it. Die 2 plus plus. Alright, that's my complete while loop. And now that I've got this complete while loop, I can come in here and I can do things with it. I'm going to leave that same comment here to remind myself when I need to read through this. It reminds me of how many times this loop has gone through. So for every value of die 2, we're going to have a different combination of the dice. So what I'm actually going to do is I'm going to get rid of the printing out of die 1 here. And instead I'm going to print out both here. So, die 1 is one value, die 2 is another. Oh, I could put the total here as well. And total is another value. Alright, so die 1 will be one of them, die 2 will be the second one of them, and the third one will be die 1 plus die 2. That's getting a bit long there. I'm going to set up my brackets here so that I've split the line, but it's still pretty readable. Okay, so this thing is saying die 1, the value of die 1, the value of die 2, and the total by adding the two together. So this is good. This is getting us closer to what we're looking for. We're looking for all the possible totals that can come out of two dice being rolled. Let's save this and compile it at least and make sure that this worked. Got another one of those warnings there, but I'm not worried about those. There's my compilation command. It compiled. Sometimes when code compiles, I get a little bit scared because it means that there's probably an error in it, but the compiler didn't pick it up. There'll be a different kind of error in it somewhere. Yes, people are having chat there about why we're putting a loop inside a loop so that we can see all possibilities. So the loop inside the loop is nearly like a multiplier that says we're doing this many times multiplied by this many times. So we're going to use some smaller dice now so that we can actually see what's going on here. So let's do a 4-sided die and a 6-sided die. See what we get. Oh, it's a bit messy. Die 1 is 1, die 2 is 1, total is 2. Die 1 is 1, die 2 is 2, total is 3. Okay, I think it's working, but because it's so messy, I can't really read it. This is the thing where like the program can be correct, but if it's not readable to a human being, it's like, this is not very useful. So, what I'm going to do is put a new line here every time it prints stuff out. We should be able to read it more easily now. Compile that. Run it. Okay, what do we have? We had a 4 and a 6. Okay, let's look at our dice statistics. When die 1 is 1, and there's a bunch of them there, die 2 can be 1, 2, 3, 4, 5, or 6. And here are our totals. So those are the possible totals when die 1 is 1. And then here we've got die 1 is 2, and all the possible values of die 2, and there they are. And I'm going to trust the maths because it's sort of looking correct for most things I'm seeing here. This looks like it's getting us all possible outcomes of the two dice. So for every roll of die 1, there's 6 rolls of die 2, and there's the 4 possible rolls of die 1 are all listed there. So there's 4 rolls of die, 4 possibilities for die 1, 6 possibilities for die 2. This should be 24 total possibilities, and here we have all the possible values that they could be. So, okay, Michael. Oh dear, he forgot the /n. You were warning me as I was typing it, weren't you? Gene is asking what I mean by the amount of times the loop has gone through. Yeah, the actual number of times that this loop has been run. And so we remind ourselves of how many times that's happened by putting these comments in here. Sometimes it helps us because it helps us think about how we're constructing things, to have comments letting us know how many times things are happening. Okay, so I now have all of the totals. What was I going to do next? I think that my final goal was I want to know what the odds are of rolling a particular number. So what I want to do now is I want to check these totals potentially against a different number. So we can see all the possible die rolls, and we can see the totals listed. If we wanted to, we could count how many times the dice were rolled. But let's look at isolating a number. Actually, we are going to count that as well, but I don't know if we'll do it right now. But we're now going to try a target number, and we're going to see how many things match that target number. So here we have another variable. I'm going to chuck it up here. Target value. And we're going to ask our user for another piece of information. Please enter the target value. I'm going to scanf this again as a number. Again, just to reiterate, we're not going to go into the depth of what to do with invalid input on something like a scanf. We will talk about that later. And we're going to put this thing in target value. Right, so now we have a number that people were trying to roll with the dice. And so while we're looping through, we're getting this total. And we might want to check if the total is equal to the target value. So the total just sort of sitting here as something I added together inside my printf is not quite as useful as it could be anymore. I want to actually calculate the total every time I get a combination of two dice. So here's my total is equal to die 1 plus die 2. So the values of the dice at this point in the roll here, I'm going to put into a variable, which means I could use that variable here instead of recalculating that. Okay, so I've still got my printf, which has the total. But now what I want to do is I want to say, let's only print out the combinations that actually match that total. So I can make an if statement here, and I can say if the total is the same as the target value, that means that the roll of the dice was exactly, when added together, was exactly the same as the specified target value. Then I print out this combo. So I'm going to cut that with Control X, Control V here to paste. My printf has been unindented a little, so I'll put that back there. So now what I'm saying is print out the dice combo if the total matches the target. I guess I'll call it target value. Okay, so now I'm actually restricting what's happening in my loop. My loop is still going to go through all possible values. But a lot of those possible values that it goes through, it doesn't do anything. Because it hits this if statement and it says, you didn't match a target value, I'm just going to skip past you. I'm going to skip past you and then exit the loop and then go on to the next loop, right? So this is nearly like we're searching through all possible values, and the ones that match the ones we want, then we're going to print something out. Okay, let's try running that again and see what it does. So press up twice to get to my DCC command. Press up twice again to get to the command that runs the code. I'm going to go with two 6-sided dice now because I think we're more familiar with two 6-sided dice. That's the standard set of dice for a lot of board games and craps if you like casino games. I don't know if everyone's over 18 yet, so, you know, not that many people play craps anyway. It's like a, what are we talking, like 1920s Prohibition era gambling game. Alright, target value of 7. 7 is actually the average value for two 6-sided dice, so we'll see how often this comes up. And we get told that there are 6 possible values, 6 possible rolls of the two dice that add up to 7. So, if die 1 is 1, die 2 is 6, that adds up to 7. If die 1 is 2 and die 2 is 5, that adds up to 7, etc. All of these add up to 7. We have still, in our while loop, we've still gone through all possible values, but we've just isolated with this if statement, so we only printed out the values if they matched our target value. Tiara's asking if I will upload this code to the course. Yes, I will definitely upload this code to the course. Charles, will you shoot us if we use continue? I will not shoot you if you use continue, but I might look at you funny. There are ways to use certain keywords inside loops. I'm not going to teach any of them in COMP1511 because we can do everything we need in loops without using the weird stuff. The reason why I don't use any of the weird stuff in loops, there are keywords you can use in loops. They're called break and continue. I will not use the weird stuff in them because they break the flow of the code. If you use those, you can't just read the code like straight up and down and understand what's happening, which is why I don't use them that much. If you do start using those, you've got to be really careful because if you scan it and read it and you miss that one word, you miss the entire idea of what's going on. Whereas the way I like to write the code, especially when I'm teaching people the first time, is I will write it so that you can just scan it and read it, and you don't need to have that extra knowledge of those special things to be able to get everything done the way you want it to get done. Yeah. Chicken washi. Oh, Mason is asking about the target value thing. So the initial question that I proposed for this demo was, can we work out the statistical chance of rolling a particular number on a set of dice? So that was the reason that this program was being created. So the target value is like, okay, can we roll a 7 on 2 dice? If I roll 2 dice, and what are the odds of me getting a 7? So what I'm getting to now is I've isolated out of the possible combinations of the dice, I've isolated how many of them meet the target value. So if I know how many of them meet the target value, I also have a way of finding out how many times I've rolled the dice in total. I've now got a fraction. And if I've got a fraction, then I can create a percentage for how many times this thing's happened. So let's start putting that bit of it together. So every time we roll one die and then we roll the other die, so every time we have a value for die 1 and a value for die 2, here where we're creating a total, this is now allowing us to say this is how many times we could roll the dice. So this is how many possible combinations of the dice there are. So what I might do is create a new variable here. Number of combos, number of combinations of the dice, and the number of combinations is going to be 0, but each time we roll the dice, it's not really rolling, every time we pick values of the dice, that's another combination of the dice. So what I can do there with this num combos that starts at 0, I can say num combos plus plus. So the number of combos that we have is the total number of times we match the dice together. So if I had 2 6-sided dice, this should equal 36 by the end. If I had a 4-sided dice and a 6-sided dice, it should equal 24 by the end. So there's that kind of thing. There's another way I could do this. I didn't even have to do this with the loop. I could just multiply the numbers. However, I'm trying to use as much looping stuff as I can. So this is the number of combos, and this is the number matching, the number of matches. So before we've made any rolls of our dice, there are no matches. But every time the total equals the target value, then the number of matches goes up by 1. So num matches plus plus. You can see why I'm doing this in here. I'm doing this in here so I can show you all the kinds of things we can do inside loops, right? So these numbers are outside the loop. They're outside the curly brackets, which means every time we change it, that change persists outside the loops. And I can use those numbers after the loops are finished, which is actually what I'm going to do, right? Because after these loops are finished, I'm going to be able to say how many possible combinations of the dice there were and how many of them match the target. And I will do that here with a printf. I can just put some enter keys down here so this is in the middle of my screen. So print out of this many combinations, this many matched the target value. So I can print out this information if I want to. So it was num combos, and here we get the niceness of me naming my variables well, is like if I'm looking for the number of combinations, it's the number of combos. If I'm looking at the number of times we match the target value, it's the number of matches. So I like variable names like this because it's really, really easy to do this and not get confused. I'm going to split this on multiple lines again, like so. Okay, so my dice stats program now should be accumulating these two values. They have to start at 0 because I'm going to add to them. So I don't know what they were, but I'm going to keep adding to them. So if they start at 0, saying I haven't seen any of these yet, and they add 1 each time I see something, they should accumulate a count of how many times these things have appeared. These are actually often called accumulator variables. If I was to not give them a 0, then I can't add something to a number that has no value. So I've got to remember to give these a 0. Control Z to put that back. Mason is asking if I should put it in the if statement. Maybe now that I've done the two different accumulators, you can see why one of them is all possible combos and one of them is only the combos that match, hopefully. Okay. I don't think there's anything else here that pertains particularly to this code. So let's compile this and run it. And we'll do the same example. 2 6-sided dice, rolling 7s. All right. Out of 36 combinations, and we were talking before about how there are 36 combinations of the dice, 6 matched the target value. Cool. All right, this is good. So we're getting closer, right? If we want to, we can even just look at this and go, okay, this seems to suggest that if anytime I roll 2 6-sided dice, there is a 1 in 6 chance, because if it's 6 out of 36, it's 1 in 6 chance that the outcome is going to be a 7 for this. Someone was asking where we put something. Why do we put the iterator at the bottom of the while loop instead of the top? Alec, there is a reason why the iterator is there. Because I'm using the values. So for example, die 1 here, I'm using die 1 as a value. So if die 1 is equal to 1 for the first roll and I use it here, then it's equal to 1. When I do this, it becomes equal to 2. So if I did this, then the first time the loop would run, die 1 would be equal to 2 and I would miss out on that value of 1. So what I usually do is I have it at the value I need when the loop starts, and then when the loop ends, I change it to the value it's going to need to be in the next time the loop runs. So if I wanted to add 1 to it now, I would have to think about what that meant. So if I was going to add 1 to it here, then maybe I would have wanted to start at 0 and maybe I would check things differently. So you could do it that way if you want to, but I'm showing a simple way of doing it where we don't change the value until we're finished with it, and we change it to what we're going to need the next time the loop runs, and also we change it to something so that it gets checked in a reasonable way from the way that we're planning on doing it. Mason is asking, can we check more than one condition in a while loop? Yes, we definitely can. This question here can be a multi-part question using the same kind of things we're doing with our if statements. Okay, so one last thing that we might want to do now, because we were asked to give the percentage chance, so I'm going to print f here. Something percent chance of rolling a target value I'll just leave it like that for the moment. Percent chance of rolling the target value, and the percent is going to be num matches divided by num combos and the target value. Alright, that's gone over the line, so I'm going to bring that down here. Bonus marks for anyone who's yelling out, "It's behind you" right now, because there's something going on here that's interesting. And I will show you what's going on here when we run this now. Okay, so we've got the same kind of thing. Num combos, num matches, and I'm dividing them. Oh wait, if I'm dividing them, I'm going to get a value between 0 and 1. So if I want a percent chance, I'm going to need to multiply that by 100. I'm going to put some space in here to make it nicer looking. Okay. You already know, some people already know that something might be happening here, but I'm going to run this now and just see what happens. Those of you who already know the answer, don't say it yet. Don't say it in chat yet. All right. Okay. So I'm going to compile this, and then I'm going to run it. Let's look at the same example. 2 6-sided dice, target value of 7. 36 combinations, 6 match the target value, 0% chance of rolling a 7. What? How do I get 0? I had like 6 out of 36. How do I get 0? And there's a whole bunch of people going, "It's right there! It's in the code!" Okay. Look at all this message retracted. Thank you everyone for retracting your messages. Okay. There's a few people who've seen this. There's a few people who are looking at this and going, "Hang on, what's going on here?" Yeah. Okay. These are 2 integers. If I divide 2 integers, what happens? It goes to an integer and it drops all the fractional values. And since num matches and num combo is going to give me a fractional value that is between 0 and 1, it's nearly always going to be 0, unless it's 1. If it's 1, then that's the only time it doesn't drop the fraction. Otherwise, it's going to drop the fraction. So, let me go back to my slides. I had this trick set up beforehand. Okay. Recording results. I've already done all this in the code itself, so I don't need the slides for this. Okay, output the percentage, this kind of thing. The percentage was num successes over num rolls, so I named it differently on the slides. I do like to actually write the code live in front of you, so not everything's going to be exactly what's in the slides. It's going to be what I thought of at the time. And also whatever input I get from people, I will often do that. So there's an issue with this code. It outputs 0% a lot of the time, and it's not supposed to output 0%, but it does. And we can even see that it's counting the successes correctly, but it's still outputting 0% a lot of the time. And this is the division in C thing. So I mentioned this last week, and I wanted to show an example of it. Integers throw away fractions when they're divided. Num successes over num rolls. I think we had num matches over num combos were always between 0 and 1. Anything less than 1 will have its fraction drop, so we need to deal with this. There's a few ways we can do this. Doubles are definitely going to help out with this. So, a couple of ways we can get around this. One way is I could do this. Double num matches is equal to 0. So I could say this thing is always a number with a floating point with decimals and fractions in it. If I compile and run this now, oops. Warning, format specifies type int, but the argument has type double. Yes, that is interesting. So that's a double there. This is remaining a double when this here is an integer. So let's output it as a double instead and see if that warning is still there. Right, we're getting another thing here where we're saying num matches and we're saying this is an integer, but I put a double into an integer. So let's try it here again. Okay, this might work now. Let's run it. I'm pressing up until I get my run command, and we'll see what it looks like. Because, just to give away the punchline, I'm not sure I want to do it this way. So let's just see what it looks like, and you see what you think. Okay, so we have 6 dice, 2 6-sided dice looking for a target value of 7. Okay, out of 36 combinations, 6.0 matches the target value, 16.66666 rounded up to 7% chance of rolling a 7. Okay, this is pretty good. This is sort of working. There's some weirdness going on though, because this doesn't look right to me. These are discrete values. They do not have decimal points. I should not have a decimal point on this thing. So me changing the type of a quantity to something that it is not may have allowed my maths to come out correct, but they're really confusing the situation. So this is not the way that I want this to happen. I'm going to change this back to an integer because it is an integer. It's a whole number. There's no fractional matches here, so I shouldn't be using the double there. And this is going to go back to %d. This means this problem still exists because these two are both integers. And I'm going to actually turn that back into just a decimal percentage. Actually, maybe I'll keep it as a floating point percentage. But let me show you what I can do with this to turn one of these into a double, because I only need one of these values in the division to be a double for this whole thing to be able to do a fractional a fractional division, to keep its fractions like as a double. So all I need to do is this really funny thing here. I don't know if I need to put brackets around that. I'm going to put brackets around that just to be safe. So when I type a number in C here, it gets a type. And even if it doesn't have a variable, it has a type. So the type is going to be an integer or a double. I've just made this into a double by saying, even if I keep the value at the same point, like I think it's 6 in the example we're using, if I times this by 1.0 here, it becomes 6.0. This little thing here has actually changed num combos into a double that's the same value as the integer num combos was. So this expression here in the brackets is a double that is equal to 6.0, and I can do that without changing, this one's num combos that I'm changing here, without changing it to a double itself, because it shouldn't be. It should be an integer because that's how it should act. But just changing one of these into a double will change the result of this division into a double, which will allow it to keep its fraction, and then I can multiply it by 100 and then output there as a double. So let's look at this in action and see if this looks different from what I just did. I'm going to compile, going to run that. 2 6-sided dice looking for a 7. This is better now. These remain integers, and they remain being output as integers because that's what they are. You know, we should keep them what they are. But we have temporarily, just as we're outputting here, we've temporarily changed our division so that it acts as a double division without necessarily having to change any of the variables themselves. So we can use the double just with this little trick here to convert this thing into something that looks like a double enough to convince the maths to give me a double as the result. And then we can have our percentage like that. Yeah, Dean's sort of explaining that there, where 1.0 is a double, but 1 is an int. Yeah. Yes. Luca is saying another solution there which would definitely work. So let's look at another way we could do this. Another option is I can have a double here called percent chance is equal to I mean, we're still going to do the same thing. This. If I do this, convert one of them to a double temporarily for this division, then this double percent chance will store the percentage chance. If I didn't do that, and I'm telling it to make a double out of these two integers, it still won't do it because these two integers will do their division first and resolve that before they can put a number in here. So they'll resolve this to 0 and they'll put a 0 in there. It'll be a double, but it'll still be 0. Okay, so we've got a lot of people who have obviously done other languages, talking about casting and stuff like that. What I'm going to do is, because we're at 6:08 now, and I know Dean's probably going to have to go to the help session, just so that everyone knows, the help session is running whenever, or Dean might actually be running it already now, so if anyone wants one-on-one help with things, so if you have configuration issues or anything that's particular to your code, you want someone to look over your code, feel free to hop in the help session. If you want to ask questions about the stuff that we covered today here, stick around, and I will also stick around to answer questions with everyone. Let me just take a break, have a little sip of water so that I can ease my voice, and I'll come back and answer questions. Also, yes, if your tute has started, your 6 p.m. tute has started, you should go to that, because you can ask questions there if you want to instead. Okay. I'll be back. Alright, I'm back. Just had a bit of a stretch. I always find that my brain kind of melts down by the end of a 2-hour lecture. I'm assuming that yours does as well. Actually, that's one of the nice things about having chicken in the middle, is that it just sort of gives you some time to switch your brain into a completely different mode. I think if I barreled through and like fully taught for 2 hours straight, I don't think any of us would really survive that. I don't think that's something that, you know, it's all that good for the human brain. So it's nice to have that little break in the middle, chill out, hang out with something super cute, and then get back to work. So, did anyone have any questions? I don't. Sorry, there's just too much stuff. I'm not gonna scroll back, but if anyone wants to ask questions now, we'll start the questions from this point in chat. So Mason's got one there. So you want to make shinies? What kind of shinies are you making? This is the most character efficient way to make it so the system takes a user input of yes or no on whether to display the dice rolls done by adding an AND condition in the if statement and the second while loop. So you're thinking of the idea of do we display certain parts of the code but not other parts? Sorry, not code, but display certain parts of the output. So you're thinking of, did someone want the combos or did they want the percentage, and being able to turn one or the other on or off. If we want to, we could ask the user to give us an option one way or the other, and we could say, do you want this option or this option? and they could type a 1 for one option and a 2 for the other, and we could store that value in an integer being their choice. And here we could do if else's, saying if the choice was this thing, then we do this. If the choice was the other thing, then we do the other thing. I don't know if that's exactly what you're asking there, Masony, but maybe. Yeah. Oh, Michael's asking about printing the percent symbol. So when we have percent is initially going to say there's an issue here. Well, not an issue, but this is start of a format, like a %D or a %LF. If we want the actual percent symbol to come out, we can put a second % there. So if I do this now, compile and run this, we should get the number and the actual % symbol. So we'll compile that, run that. 2 6-sided dice. Let's look at an 8. That's a different percentage. There you go. The % there will appear. So there's a slightly less chance of rolling an 8 than there is of rolling a 7 on 2 6-sided dice. UG is asking, when are the help sessions held? Are there any timetables? Let me quit. Oh, I didn't go to my final slides. I had challenges and stuff. Oh well. That's okay. I think we taught enough. What are we looking for? Web CMS 20T2. Here we go. So here on the course website, there is help sessions. Help sessions have a bit of information about how to get onto the help session. So we've got a little system that you can queue in, and it's called Hopper. You can actually just go to that website and just go, here's my ZID, here's a brief description of the problem I'm having I'd like help with, and then you hop in the queue and someone will see you. Week 2, Thursday 6 to 8 p.m. So at the moment, we've got Thursdays 6 to 8 p.m. We'll have regular help sessions. As we get into assignments, more help sessions will appear here. So it's pretty slim timetable for the moment, but it's happening right now. So Dean's there right now. So Dean, who was helping us out earlier. So if you need to, you can always come back here. And during term, as things get busier, more help sessions will start appearing in this list here. Okay. Masony's asking the user for yes or no in whether they want to see all the printf listings. We don't yet, Masony. We don't have input for characters. We've only got input for numbers for the moment. So we will definitely be looking at it soon. 2 weeks, 3 weeks time, I think. It's not far away, but for the moment we're going to learn a bunch of programming constructs just with the numbers, because the added complexity of the characters and strings is something we don't need when we're still learning the basics of just how to construct a program. So it's all kind of like I've put a bit of effort into like just doing one thing after the other in an exact kind of timeline to hopefully allow people the smoothest transition into learning how to use C. So for the moment we're not using any characters like yes or no or anything like that. Oh, Tom's here. Hello. Leon, yes. The lecture ends at 6. I have to end the official content for the lecture so that people can go to tutorials, and also there's a help session, so people are going to want to go to that. I am just answering people's questions now, though, so if you had any questions, I'm more than happy to answer them. So we've got the code still here. Yeah, Tom's saying week 4 or 5. Yeah, I think it's week 4 or 5. I think it's week 5. We'll see. I do have a plan. I just don't memorize it entirely. Yes. Yeah, Jeffrey's answering the same question. Yeah, the timetable in the course outline will have when I'm planning on doing characters, because I know that matches up with the lectures that I've already written, and I'm using nearly entirely the lectures I've already written. I'm just doing little edits as I go. Oh, Dean's saying hi to Tom. Leon's asking when we get our assignment. That will appear at the end of week 3. So I think usually Saturday or Sunday at the end of week 3 is when we release it, and it'll be due at the end of week 6. So it's like nearly exactly 3 weeks to work on it. Yeah, Tom's saying the same thing. Yes, the hopper tool sounds really cool. Tom wrote hopper, so there you go. Morgs is asking about the times point one thing that I did here. My little numerical hack. So, so Jeffrey, I assume you've done some Java before. Don't worry if you don't have to answer every question. Like you can chip in when you're sure, and if not, you can just wait. One of us will help. You don't always like you're a student here. You don't have to be a font of knowledge or anything. It's not really that important. Okay, so Morgs is asking about the times one. Let's have a look at some of the possibilities that we can get here. So what I'm going to do is I'm going to do printfs for all of these things so we can see this. So this one shows us the number of combinations and the number of matches. So this is this kind of thing, 36 combinations, 5 matches. So let's do another one here that says this divided by this is equal to this. And we've got the number of matches divided by the number of combos is equal to this thing, num matches divided by num combos, without that bracket. Okay, so this will show us the output if we divide these two integers. Let's quickly run this and just see that so we can establish what's going on here. Again, we'll just use two 6-sided dice because those are the dice that we tend to recognize. Let's look at a different number. How many times can we make 4 with two 6-sided dice? There's 3 ways to roll 4 with 6-sided dice, which means that 36 combinations, 3 match the target value. 3 divided by 36 is equal to 0, even though this should be giving us an 8.3% chance. So what's happening here is division by integers. When two integers divide, they will provide an integer as a result. The issue with integers, and this is something that we're building on from stuff that we were talking about earlier, is that anytime an integer has a fraction on it, it will throw it away. So the fraction here is 0.08333 repeater. So whatever, 3 out of 36. What is that? 1/12. So instead of giving us 1/12, because it's an integer and it can only do whole numbers, it gives us a 0, and it knows, well, it doesn't entirely know, but that there was a remainder there, but it doesn't deal with it. It just lets it disappear because the integer has no way of storing that fraction or that partial number. So that's why we get a 0 here in the 3 divided by 36. Are people asking anything else? Yeah, Andrew, he knows. They know. I didn't do it. I did not. Anyway. Yeah, so if anyone hasn't seen the movie The Room, it's not worth watching, or it is worth watching. It's just, yeah. But there's a line in it. It's like, oh, hi, Marc. And that may or may not have been used on me ruthlessly and continuously for the last, like, 5 years or so. Anyway. Okay, so going back to Morg's question here, because that's the actual question that I do want to answer. Because the two integers being divided will throw away whatever fraction the answer is, we're going to get a 0 for like anything. So if I do this with other values, so let's look at the 7 that we were trying to get, should have been 16.6 repeater percent, still a 0. The reason with that is dividing an integer by an integer, we get an integer as the output, and the integer will throw away the fraction. However, if we can convert either one of these things to a double, a floating point number that can hold fractions, for example, like this changes one of them into a double, because this expression in brackets here, I don't even know if we need the brackets, but I'm leaving the brackets in there for now. This here is another mathematical operation, but what it has is it has an integer on one side and it has a double on the other, because I've introduced the decimal point, even though it's 1.0 and the value 1 is something that could be an integer, because I said 1.0, I have said to the computer that this is a number capable of having a fractional value, so it has a floating point. When I multiply these two together, the output is going to be a double as well. It's going to have a floating point. So the num combos, if it was 6, oh no, number of combos here happens to be 36, and I times it by 1.0, this thing here, num combos was an integer, but this whole thing here, once I resolve it, once I evaluate it, sorry, is the technical term for that, this becomes a double. So the value here becomes something that can hold a decimal point. Even though it's the same number as that, it'll have a 0.0 on the end. And then when I take that thing that has a decimal point and I put it into this division, and it could have been the first one or the second one that went into the division. So long as one of these things in the division has a decimal point in it, then the whole division and its outcome will have a decimal point. So this was a little hack to convert num combos from an integer into this expression here, multiplying it by 1.0, which turns it into a double, which allows this division to then be done as a double, so that it won't throw away the fraction that it had. Okay. I don't think Morgs has answered again, but yeah, let me know if that's getting there for you, because that's all I did, is this little trick to make it look like a double. Everybody loves me. And Eric just finished the word addition challenge. Congrats. And you have over 40 ifs. If you want an extra challenge, see if you can get that down amongst the 20s or even less. Liang Chao's asking me what game did I play back in the day. Are you saying that I don't play games now? I guess one thing that I could say in terms of games that I played back in the day, I don't think I still have it, but I used to have a set of dog tags, which was the prize for being part of the team that won the CompSoc. It was called CompSoc back then, not CSC Soc, but the CompSoc team's Quake tournament. No, it was not Quake. It was Quake 3 tournament. So I used to have a set of dog tags with my my gamer tag and stuff on it and stuff like that. So I played a lot of Quake 3 back in the day. A little bit of Counter-Strike. Like back then there weren't that many games, so we just kind of played all of them. StarCraft 1. Warcraft 3 was the game, I think, when I was in uni that I got the best at. So there was one time that I nearly beat my Korean friend in Warcraft 3, and I think that was the best I was at gaming. Having said that, oh, Morgs is saying it makes sense. Great, good. World of Warcraft, I think, is the game that I put more hours into than any other game. Which tends to happen to anyone who plays World of Warcraft and really gets into it, is like you kind of get sucked in and never escape. Jeffrey was asking me about the final slide. Okay, let's have a look at the final slide. It was here. So the last couple of things that I was going to say, if people are interested. The challenge. And this is a challenge specifically because it's got nothing to do with what we're teaching in the course, but it is something that someone even asked about today, which was, are we worried about how much work the program does, and do we want to like optimize things to make it run with less operations, in a sense? Like, I'm trying to keep this as simple as possible. And so this is the challenge, is did we need to do all this looping to get these results we're looking at? Was there another way to do this? And I'm saying that yes, there is definitely a much simpler way to list all the roles that up to a target number, and there's also a simpler way to find the total number of roles and stuff like that. If we take the theory of how numbers work and how combinations work, we could have done this with a few simpler mathematical operations instead of raw looping through everything and accumulating these possibilities. So if you're interested in a challenge, that's something that's really cool, is can you get the same results as this program without having to do like the full-on double loop and stuff like that? Because I know that there are potentially ways to do this. You could turn that code there into something that's actually much, much more complicated in terms of the code and how it's written, but will ask your processor to do less work to get the same result. And I don't really want to talk too much about this because it's super, super complicated stuff. Like, there are people whose entire career is based around taking other people's code and making it run faster. So there's people who, I used to like kind of see some of this stuff in the game industry where you'd write all this code to get your game running, and it'd be like, okay, good, it runs, and it runs at a certain frame rate, and then someone would come through and go, okay, let's make this run at a higher frame rate. So how much work in 1/60th of a second is happening in the game to make the frame rate kind of kick up to the next level? And you get people who would go through and they would like strip all of your code of all the things that make it look nice and understandable and turn everything into like this one tiny block of memory that did the same thing as your entire expansive bit of code did. And I never really got my head around what they were doing, but I kind of, theoretically, I understand it, but I could never quite do it all. But you could get, I don't know, depending on how well you wrote your code to begin with, but you could get like a 30-40% increase in how well your code runs if you had someone who was really good at it, to modify your code to know all the tricks to make it run faster. And so there's a little thing here where this could run faster if you do it. Oh, wait, my face is in the way. Could run faster if you do it differently. Yeah, so Michael, hopefully I'm answering that question now. It's not necessarily simpler. It's less stuff that the CPU is doing. So less instructions that happen. So for example, we run through all 36 possibilities of the two dice. You can get all these results without running through all 36 possibilities. So without cycling through that double loop, you could mathematically just go, okay, there's some of these are only possible in certain ways, So we'll see how it goes. So Liang is saying those are the ones that you play? Dota All Stars. Oh wow, Wolfenstein Enemy Territory. I played Enemy Territory Quake Wars when it came out. I was playing that competitively for a little while, but then like it sort of fizzled. The game fizzled because it just wasn't as good as some of the other games. SOF2 is Soldier of Fortune 2, isn't it? That's like some old stuff right there. I played Delta Force for a little bit. That was okay. It was like a voxel rendering game, which made it really funny because you could actually snipe at pixels in the distance and you'd hit people, which was a bit mean. I played Dota a little bit, but not much. I think I missed the whole MOBA train when it happened. And it's kind of like, MOBAs to me feel like I missed the bus, and a bunch of my friends got on the bus, and now I can't catch up. It's too far away, and I can't run that fast. And if I get on another bus, I'll still be permanently behind them. So I've just kind of like just sort of abandoned. I've got friends that work at Riot, but like they still just sort of haven't really gotten into the MOBAs. I think I'm too old and slow to be good at MOBAs now. I love my action RPGs though. Played a lot of Diablo 3. I'm playing another one called Inquisitor Martyr at the moment, which is a little dark horse hit. I think it's actually a really good game, but no one really cares about it because it didn't get good until like 2 years after it was released. Anyway, Yuji's talking about Warcraft 3 and the remake. Have they already finished the remake? I knew that they were doing it, and I was like, oh, I'm going to play it all again. I'm going to play through the Frozen Throne and all this kind of stuff. And then I just didn't go back and look for it, so I don't know if it's already been made. Yeah, Michael, I heard rumors that the Warcraft 3 remaster was not as good as it could have been. And so I just sort of held back from it instead, playing other games instead. I used to Huntress Rush in Warcraft 3. Um, and then when I when I changed over, I started doing mass frostworms, which was really, really scary for other people because I could tech to them much faster than people expected. And so when the frostworms started appearing, a lot of people would just fold at that point because like you didn't have that much anti-air, and these things could kill pretty much anything. So they were like really powerful. Anyway, so Jeffrey's saying, not sure how successful you'll be with the challenge here, converting things. Let me show you a simple one. I'll show you a simple thing that takes some of the work out. So, this one here, number of combos. So we have number of combos equals 0, and then we're adding to it like 36 times. So that's 36 mathematical operations. Instead, I could do this. Number of combos, actually, let me just put it below, because I don't want to put this in the code I'm giving people because it's going to confuse because it's not the thing I actually taught. But if I wanted to, I could do this. Num combos equals die 1 size multiplied by die 2 size. And then I get rid of this line. And I'm done. I've done one multiplication instead of every time I come through the loop, I'm doing this accumulator. So I'm going to that piece of memory and writing to it. This means that I've done, it's not exactly, but kind of, I've done one operation instead of 36. So that's a little thing that I could do. And I kind of hinted at that while I was writing it, but I didn't want to do it that way because what I was trying to show everyone is like, okay, these are stuff we can do in loops, and that was more important. I'm going to put that back the way it was. Okay, oh Dean, you need to be made a mod. Let me do that afterwards because I've got to go into my YouTube settings and stuff to do that. Michael's saying that you can make a loop that only runs for the possible number of combinations, but I need 2 else-if statements outside the loops. Is that simpler for the computer? Potentially. So, Michael, if you reduce the amount of stuff, especially this loop in here is the one that runs 36 times. So the least stuff we do in the 36 times thing, the better. So if there's a couple of things outside that only run once, as opposed to running multiple things in here, that's probably something that would make it better. I don't want to go too deep into that, right? I think that that's going to take you... It's a cool thing, and it's something that you will need to do later, but here in 1511, that's going to kind of push you off the path, right? So that's exactly the thing I was talking about before, where we get distracted by distracted by interesting problems, and we forget to solve the actual problems. We get distracted by something that's cool over there and go, oh, I'm going to make this program run the fastest it could possibly run. And then, 3 days later, when you haven't done any of the other lab exercises except this one that you fully optimized, then you end up in this situation where there's all this stuff that you haven't learned because you've been too deep in one thing and not broad enough at all the different topics that we've been learning. So yeah, that's okay. Oh, Roy is saying Path of Exile. Yes, I played a lot of Path of Exile as well. I think that's really cool. I mean, Path of Exile is also a cool story because they're a bunch of New Zealanders, and I always love seeing local game studios do big, amazing things. So I think, we always claim New Zealanders as if they're Australians. But yeah, so that's always fun. Liang's asking me about current first-person shooter PC games being console ports. Okay, before I answer that question, Liang, I want to talk to you about something that is, I don't know what the exact term for it is, but it's something along the lines of misplaced authority. So, because I'm your computer science lecturer and I happen to play computer games, you're asking me questions about my opinions about things. And I want to say that if I have any opinion on computer games, it's still only one person. Granted, I taught people how to make computer games for 3 years, so I do know a hell of a lot about how to design them and things like that. But I still don't want you to use my authority as your COMP1511 lecturer to mean that I'm right about computer games. Because right here and now, the stuff I'm teaching you about looping in C is stuff that I've researched in order to teach it correctly. But I have not researched the deal with console games being ported to PC and what issues come about. I mean, off the top of my head, I can think of many. Yeah. Oh, Jeffrey, you don't do live for the 9 a.m. I think that's probably going to happen for a lot of people. So anyway, Liang, to your question, I think that there are issues there because I think that the design of an interface is very, very different for a controller and a TV than it is for a PC with a mouse. So I've noticed some really, really big issues. I played a lot of Borderlands 3 recently. As I said, I love my ARPGs. I don't know if it's like I love grindy randomness in my games. I don't know why, but I do. Um, and Borderlands 3 has on PC a very, very difficult to use fiddly interface that works really well with a controller, but like has some significant issues with a mouse. Um, and I think that's because it was designed from the ground up as something with a selection that moves around the screen, as opposed to something where the mouse can just click anywhere on the screen and make that selection. And so there were a lot of issues there. It didn't affect the gameplay itself, but the design of the interface was finicky. Um, I don't know so much about other games that I've seen recently. I think there are a lot of games that are influenced by console development, and they've done really interesting things along with that. I think Overwatch is a really good example of that, where it's yes, it's a first-person shooter, but it's also like just a first-person action game because there's heaps of characters in that that are just not shooter characters. I play Reinhardt, by the way, but you get a lot of positive influence there from the design of action adventure games and how they influence how first person shooters act nowadays. Because first person shooters act very differently when they were the primary and only form of game before third person games became more popular than them. Um, so I think that there's a back and forth. But I think that there's definitely a bit of stuff being lost in good interface design. Again, I'm always going to end up back on the things that I have expertise in. I used to teach part of the HCI course. If you're going to continue in computer science, there's a course called HCI, stands for Human Computer Interaction. Apparently, it's been like 5 or 6 years since I did it. Some of the notes in the tutorials, because someone I know is tutoring it, some of the notes in the tutorials are still the notes that I wrote. So I'm pretty happy that my teaching is still in that course. Yeah, there's a lot of things with the human interface that shifts in weird ways. If you're designing it from the ground up for a mouse and keyboard versus designing it from the ground up for a controller, they're going to be very different. And you nearly need two whole teams to work on the same game from different directions to make it work. I reckon a good thing to look at would be how Blizzard changed Diablo 3 when they ported it to console. So this is something going in the opposite direction. They changed things like the camera and all the controls and things, and everything went really different like that. So people just ask me random questions now. Roy's asking about Dark Souls. I apologize. Dark Souls is really similar to MOBAs for me. A whole bunch of my friends got involved, and I just sort of got left by the wayside and never got around to it. I've spent a significant amount of my gaming life, like overall gaming life. Hang on, let me just, because we're not even talking about code anymore. I'm just gonna turn this into a live chat stream instead. A lot of my gaming life has been in tabletop games as well, so I could tell you a lot about high-end board games and miniatures war games and stuff like that. And that's the point at which I was doing that stuff instead of Dark Souls, so I sort of missed out on that. Heresy, indeed. The Horus heresy, the only real heresy. Dean, why are you asking me stuff here now as well? What type of music do I like? Um, I think if there's one, okay, there's two bands I think that are like super influential for me. One is the Beastie Boys, and the other is the Gorillaz. Um, so there's this kind of sensibility of this on the edges of hip hop, but doing other stuff with it that I really enjoy. I used to be a huge fan of the Bristol scene as well, Bristol trip hop scene. So Tricky, Portishead, and other stuff like that. You can kind of date how old I am by the stuff I like because like the predominant kind of stuff that I like the most is like late '90s, early 2000s kind of era. Oh my God, Warframe. Oh my God, like 2,000 hours later, and I'm like, I need to delete this game and never touch it again. Um, oh, I wonder where it is. It's actually around somewhere near my desk. Either that or I threw it away. No, I don't know where it is. Somewhere I have a bandana from Warframe because I backed it before it was a game. So I backed it before launch. And I played way too much of it. Yes, I ground Warframe. I ground or grinded Warframe way too much. Um, how many subscribers do I have? I think there's about 500 people subscribed at the moment. It's all students. It's not like a... This whole conversation's not meant to be happening right now. Anyway, I will probably cut off the video at some point in this stream where we just devolve into not talking about programming at all. When I edit this later for publication. No, Dean's here because no one needs help in the help session. That's okay. What did they raise to 27? Oh, mastery rank. Right, I get it. I was gonna say I can't remember what I am. Also, I think my mastery rank is really low for the number of hours I played because I played really early in the game, and stuff has changed now. Yeah, everyone else is saying yeah, I had to retire from Warframe. So one thing I can suggest. Okay, so here's me going back to being a lecturer. One thing I can suggest. Myself and a friend nearly failed our computing degrees because of Diablo 2. So that's something that I can suggest. Um, the super addictive grindy games, just be careful with them. Because all of that effort that you're putting into, or that time and effort you're putting into getting really good at that game, if you put that into your programming instead, you'd be like the best programmer in the school. If I put the hundreds and hundreds of hours that I put into Diablo into like any of my subjects, it was just this string of HDs. It was just so many HDs. And afterwards, I would have been like, oh my God, I'm like the best programmer. This is so cool. Instead, they're just like, yes, I had a level 100 spear Amazon, and I don't have it anymore, and it's gone now. And yes, there were some nice experiences with that, hanging out with my friends and stuff like that. But it was not necessarily the best use of my time. Yeah. Okay. Secret club of fun discussions. Well, I mean, look, I'm trying to give you, as the students, the same experience that I give people when I'm in person. And me staying 45 minutes after the end of the lecture is not that far-fetched. I've done that before with people who just wanted to hang out and wanted to ask about programming things. I don't usually devolve into like what games do I play and stuff like that. But there's 33 people still here. There's not usually that many people who hang around after the lecture. Usually people have more interesting things to do with their lives. Okay. I'm going to let the stream end here because I think the only thing happening right now is Dean is helping Roy with something, and you can probably take that to the help session and that'll be fine. Oh, thank you, Jeffrey. That was very nice of you to say you're enjoying this. I'm going to delete it all. I think, yeah. Um, I won't delete it all, but I'll delete a lot of the devolving. I think the second that I put my face in the middle of the screen and we just started talking about things, I think at that point is probably where I will cut off this video because it doesn't need to be there anymore. Yep. Okay. I'm going to wrap it up. Thank you all for dropping by. I hope you learnt a lot about loops, and I hope that the random chat afterwards is also fun. It's actually quite fun for me to just sort of hang out with you. Even though I can't hear your voices, it's still kind of hanging out. I'm wondering if I should do more hangouts where people can actually talk to me. So do it over Collab or Zoom or something like that. So we'll see how we go with that. I'm not sure. Yeah. All right. See you all. I'm going to wrap up now, and I will see you next Tuesday for more lectures and more topics.